In part 2C, we are solving systems of equations with graphs. And if you think about the last couple sections where we are drawing a single line on a graph, now we are just doing that twice on the same graph. And at first this might not seem like it has much point or is particularly sophisticated. So let's go ahead and just actually do the process real quick, and then we'll talk about why it's significant. In our first line, we see that we have a y-intercept of positive 4. So let's go ahead and graph that. And we look over here and see that we have a slope of negative 3/2. So we are going with a reasonably steep downward slope, something like that. And so for every 3 we go down, we go over 2. So we go down 3, take us down to here, and then over 2. So we are looking at a point right there. So if I were to draw this line, it's going to look something like that. My other line, let's go ahead and switch colors. We have a y-intercept of negative 4, but this time we have a positive slope, so it's going to go up. So it's going to be a graph something like that. A 1/2 slope is actually pretty gradual, so it might be something closer to this. So let's go ahead and graph that. And we have a 1/2 slope, so that means we go up 1 and over 2. Up 1 and over 2. So we have a graph that's going something like this. And so when it says solve each system, it doesn't say graph 2 lines, it says solve each system. What it's asking you to do is to figure out where do these 2 lines intersect. That is the solution to a system, is deciding where it intersects. So as we look for this intersection point, we continue to trace our axes here. So it looks like we go out about 4 where they cross here. And if we bring this back here, it looks like we're around 2 for our y. So and I guess it's down 2, so negative 2. So if I had to make a guess, I would say it is the point 4, negative 2. Now when you're solving systems by graphing, I'm not worried about you getting the precisely exact right answer. What I am concerned about is that you can take 2 graphs and figure out where they intersect graphically, and you can make a reasonable guess at where their point of intersection is. So what I'm looking for is an approximate answer when you do these problems. You'll see that some of them, again, we do not have in the typical y equals mx plus b form, so you might need to do a little bit of solving, either in terms of getting intercepts or in terms of solving for y. And so that's what we're going to do here. We're going to solve this bottom one for y. We take x away from both sides, and we have negative 4y equals negative x plus 8. And you'll always notice that when I rewrite these, I put the x term first, I put the number term last. So it comes out in y equals mx plus b form. Divide by my negative 4 all the way across, and I get y equals, my negatives cancel here, so x over 4, and I'm actually going to write that as 1/4 times an x. That way it looks more like the form we're used to. So 1/4 times x, mathematically the same. And then 8 divided by negative 4 is negative 2, so minus 2. So that's one equation. Let's do our top equation here. We're going to have to subtract 3x from both sides, leaving us with negative 2y equals negative 3x minus 6. And we divide everything by negative 2, so that we get y alone. We get the negatives that cancel, so positive 3/2 x, and we get positive 3 here. You'll notice we look at these 2 lines, they both have positive slopes, but they are different, which means they will intersect at some point. One thing to be careful about is there's going to be problems out there where you'll find that there is no solution. If both slopes are exactly the same and the y-intercepts are the same, they will have infinite solutions because the lines are actually the same exact line. They're always intersecting with each other because it is itself. In the case where it's the same slope, like if these two slopes were the same, but the y-intercepts are different, then they would be parallel lines. So this one's going this way, this one's going this way. They never intersect. That would be no solution. But in this case, we do have two different slopes. They will cross at some point. We just have to figure out where. So let's draw ourselves our graph. And in our purple line up above, we have a y-intercept of positive 3 and a slope of 3/2, which means we go up 3 and over 2, or back 2, down 3. And then with our red line here, we have a y-intercept of -2, so we go down 2, and we have a slope of 1/4. So we go down 1, or excuse me, up 1 and over 4. And so we have a line that goes something like this. I'll continue this line here. And sometimes you'll see drawing these lines straight really does matter. You can see my line's a little bendy, and I think I'm going to get a poor approximation of where they intersect as a result. So make sure you're doing your best to draw these lines as straight as possible. If we continue our axes here as evenly spaced as we can, my guess is if you follow that across, we're 3 down, and we are approximately 2 over from where the last point was. So 4 back from the x, 3 down from the y. So our point of intersection is probably around -4, -3. Point here again is that we are trying to be approximate with where these lines intersect, so we can get a graphical representation of what it is to solve one of these equations. In later sections, we're going to learn how to take these equations and solve them using substitution or elimination, so you can get an exact answer mathematically every time. But when we're doing it graphically, the important part is that we graph the lines and identify where they cross.